So Rebekah's going to be talking about the impact of climate change on catchment, connectivity and sediment mobility. Thank you, Rebekah.
Hi, I'm Rebekah. I'm a geomorphologist, and I'm interested in the mobility of sediment through landscapes and the impact that has on flood-prone areas downstream, normally of major mountain fronts. So why sediment? Well, sediment pulses into river systems can actually drive channel aggradation and migration over very short timescales. And that can move villages close to rivers in and out of flood risk very rapidly. And that's exactly what happened here in the Canale River in 2017, where the river basically inundated this village, destroyed a lot of infrastructure by depositing sediment throughout the streets. So how can we better protect these people? Well, we've seen a lot of great work today about developing flood early warning systems, and these systems kind of depend on a probabilistic hazard assessment that firstly routes a particular rain event or discharge through a mountain catchment. And that water is then delivered to the export point of the catchment, where we then use hydrological models to kind of show the evolution of the river profile, where erosion deposition happens, and where the flood waters actually leave the river channel and cause damage. But one fundamental problem with this is that we're forgetting that not only is water routed through those catchments, also sediment is, and it's that sediment that's going to potentially fill in channels and take up space that water would otherwise take up, causing changes in the flow mechanics of the water, and fundamentally also where erosion and deposition is going to happen along those river channels. So we need to really be thinking about what's controlling the flux and caliber of sediment being exported from these river catchments, and that itself is a very complex problem. It's a highly sediment transport has a highly nonlinear relationship with river discharge. So yeah, there's a lot of work to be done. So just a little bit about what actually controls the flux of sediment and the caliber of sediment coming out of river catchments. This is an image here of a riverside in Chile, and there's two types of connectivity in this image. So there's we want to think about how connected the sediment supplies are to the river system, and in the top of the image you see some hill slope deposits, and you can see they're far removed from the river channel in terms of distance. So anything produced on those hill slopes, they're not going to be actually reaching the river system. Whereas this terrace of sediment here is nicely slumping, it's producing a lot of sediment, and that's being clearly excavated by the river, and it's very available as a source of erosion and deposition. So we really need to be understanding the connectivity between sediment sources and the rivers if we want to understand something about the flux. And that also has important implications when we're thinking about climate change. This is some recent work that we published last year, where we're looking at where sediment was being sourced within the river catchment, and how connected those sediment sources were to the river system, and actually what that meant in terms of the composition of sediment that was coming out of the river channels. And what we found is in the study area in the Argentine Andes, it's a particularly arid area, but those catchments that were slightly wetter actually had better connection between their sediment sources and the river channel, and that was resulting in more sediment from upstream, upper parts of the mountain system being exported. So moving forward with my postdoc, I really want to be moving towards improving those probabilistic hazard assessments by integrating sediment into them. But first that's going to involve me looking at some connectivity modeling, both hydrological and sediment connectivity modeling, incorporating field data in that to identify thresholds for sediment export, and then hopefully then being able to move towards integrating that into a probabilistic assessment for flood hazards. Thank you very much.